So today we're going to talk about polynomials and linear factors. Now, finding the roots or zeros or solution of a polynomial means to figure out what values of x will give you y equals 0, or in other words, where it crosses the x-axis. As we previously learned, one of the ways to solve an equation is by factoring. And whenever we do factor, we use the term multiplicity when there's more than one of a particular factor. So let's find the zeros of each function and state their multiplicity. So here's our first one. In this case, let's first find the zero for this equation. In this case, x minus 3 equals 0 means x would have to equal 3. And because it's squared, that means our multiplicity would be 2. On the second one, x minus 1 means x would have to equal 1. And if we had a multiplicity, it would be to the first power, although there's really no multiplicity in this case. Let's look at this next one. X plus 1 means x would have to equal negative 1. X minus 2 means x would equal 2. And x minus 3 means, x minus 3 would mean that x equals 3. On all of these, the multiplicity would be 1. All right, so now we're going to write a polynomial function given the following zeros. Here's our first one, negative 2, 0, and 1. So I'm going to start out by writing with this. Since our 0 is negative 2, that means x plus 2. Now, for the second one, when it's 0, that means x plus 0, which I would just say is x. And then finally, for 1, x minus 1. Now, the way I'm going to multiply this is I'm going to first deal with my two binomials. So x times x is x squared. X times 1 is times negative 1 is minus x. 2 times x is plus 2x. And then finally, 2 times negative 1 is minus 2. Combine the middle terms, x squared plus x minus 2. Now, you have to remember this part right over here. It's easy to forget, but it's really x times these, which means our final version would end up being x cubed plus x squared minus 2x. And that is our final answer. All right, now we're going to factor out each polynomial completely. So the first thing we're going to do is factor out the GCF. So here's our first one. In this case, our greatest common factor would be, well, let's see, 9, 6, and 3. So that's a 3, and they all have x's, so 3x times 3x squared plus 2x minus 1. At that point, we factor. 3 times 1 is 3, but because it's a negative, I'm finding two numbers that will have a difference of positive 2. The factors of 3 are 1 and 3, and yep, their difference is 2, meaning I'm going to use the box method here. 3x squared, 3x, negative x, and negative 1. So, first, greatest common factor between 3x and 3x squared is 3x. Greatest common factor between negative x and negative 1 are not greatest, but the common factor we want to pull out is minus 1. Now, let's go on to the other side. 3x squared and negative x is just going to be x, and 3x and negative 1 is going to be 1. Meaning our final factors are 3x, because we can't forget that, times x plus 1 times 3x minus 1. Let's try another one. All right, greatest common factor is x times, in this case, x squared plus 8x plus 16. Now, in this case, If we factor out this, 16, I want to keep my color coding correct. So if we factor out this one, we're going to factor out 16 for two numbers that multiply to be 16 and have a difference of, add up to be 8. In this case, the two that add up to be 8 are 4 and 4. X squared, 16, 4x, 4x. So let's see. X, 4, and on the other side, x, 4. Meaning our final factorization would be x times x plus 4. And since it's times x plus 4, I'm just going to write squared. Okay, now that we know how to find the zeros of a polynomial function, we combine that knowledge with the end behaviors we learned, and we're going to use phrases called bump, wiggle, and cross to help us sketch a more accurate graph of the polynomial. So, for x minus c to the n power, if n is even, we have a bump, and it looks like this. If n is odd, a wiggle, it looks like this. And if n is equal to 1, it's a cross. And it looks like this. Fun fact, all three can be in one function, like this one right here. If you look, this is x plus 2 means the 0 is at -2, and since it's squared, it should be a bump, and sure enough, yes it is. Then x cubed, that means 0, and at 0 there's a wiggle, and sure enough, looks like a wiggle to me. And finally, at x plus 1, it's a cross. You'll notice it's like it doesn't even care that it's crossing the x-axis there. So, we are going to sketch the graph of this function. So, in this case, first thing we need to do is we need to find our zeros. X equals 3, and while I'm at it, I'm also going to say that since this is being raised to the first power, that's a cross. Then, x plus 1, that's going to be x equals -1, and since that's squared, it's going to be a bump. Now, I need to figure out what the totals would be, so let's see, 1 plus 2, that means our leading term would end up being x cubed. So since our leading coefficient would be positive, that means on the right side it would go up, and since the degree would be odd, on the left side it goes down. Here we go, at -1 there is a bump, and at +3 there is a cross. So down, up. And there we go. Let's try one more. X plus 2. On this one, let's see. X equals -2. And because it's to the first power, it is a cross. Now, on this one right here, x would equal 1. And since that is to the third power, it is a wiggle. And this means x would equal -3, and since it's to the fourth power, that is a, I'm just going to rewrite that, bump. Now, I need to go over to the side. This is going to end up being, since they're all x to the 1 plus 3 plus 4 is 8. So, leading coefficient is positive, and the degree is even, meaning up and up. I now start to graph. -3, up 1. At -3 there is a bump. At -2 there is a cross. And at +1 there is a wiggle. So let's see. And it would look something like that. And there you go. That's how we sketch the graph of a function. that is how we deal with factoring in polynomials. All right.